In these problems, we're looking at some graphs of functions that have been transformed, sometimes by being multiplied by a constant, sometimes by having numbers added or subtracted from them. The idea here is to kind of know what the base function looks like and to tell then which function it is according to what the transformations do to that function. This first one says f of x equals 2/3 of the absolute value of x. And let's just actually start with f of x equals x squared, because that may be more familiar to you. That, of course, is a parabola, and the basic shape looks like that. When you multiply that by a constant, if the constant is negative, it flips that upside down. If the constant is positive, it stays in this upward direction, but if it's a large number like 2 or 7 or 100, it means that the parabola goes up faster, so it's kind of narrower or squished. If it's a number between 0 and 1, so 1/2 or 1/3 or something like that, it gets a little shallower, like that. Now the same thing is going on in this first one with 2/3 times the absolute value of x. The base function for absolute value of x looks like this. And when we multiply that by 2/3, it should get a little shallower because this is less than 1 but greater than 0. So as I look around here, it looks like this is the most likely candidate. I probably want to just check a couple of points. Here's a point that looks like it's the point 3, 2. So if I put in 3 for x, would I get 2? So 2/3 times 3, well, yeah, that's 2. If I put in -3 for x, it would be -3. Absolute value of that is 3 times 2/3 is 2. So that seems to check out. So we'll say C is the right answer there. Let's look at this next one. Here we have an absolute value function again, but it's a little more complicated. Inside the absolute value, we're adding 6 to x. Now what that kind of a transformation does, and if you see this with a parabola, f of x equals, let's say, x minus 3 squared, it's going to move the function to the left or the right. So we have to figure out which. And what I would like to do is ask myself what would make what's inside the absolute value equal to 0. In this case, it would be a -6. So -6 plus 6 is 0. So the point -6, 0 should be on this graph. And there are only two graphs that have that, this one and this one. I'm thinking it's probably this one, or maybe none of these, because this one's upside down. And to make this upside down, I would need to put a negative sign in front of the whole thing, and I don't see that there. So I might want to check one or two other points. Well, here's the point -5, 1. If I put a -5 in there, plus 6 would be 1, and that makes sense, -5, 1. Here's the point -7, 1. If I do that, -7 plus 6 would be a -1. Absolute value would be 1. That appears to be working. So it looks like B is our correct answer there. Let's try one more. Now here we have a parabola. This says graph y equals x minus 3 quantity squared minus 2. Now I mentioned before this inside the squared parentheses here, this is going to move the function left or right. And then this guy here is going to move it actually down 2. So our vertex of our function is going to be 2 spaces below 0. Now, a couple of these functions I can get rid of right away. C and D open downward. To get a function that looks like that, you'd have to put a negative sign in front. And I don't see that, so these are out. So I've got a choice between these two. Basically, did it move left or did it move right? Again, I think a good thing to do here is to say what would make what's inside the parentheses here equal to 0. In this case, it would be 3. So if I put in a 3 for x, I get 3 minus 3 is 0, squared is 0, minus 2. So I get the point 3, comma, -2. And that is this point right here, which is definitely not on this graph over here. So that is going to be our answer. So that's a little bit of work with some functions and their transformations. My name is Larry. I'm a teacher at EdVision's Off Campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethisSchool.org. Thanks.